All right, my name's James, and got my co-host right here, John Reese, and we're gonna
Oh,
talk about the TRAPPIST-1 system. Um,
yeah, that's right. So basically, the whole TRAPPIST-1 system. There's a star and then seven celestial bodies. So starting off with TRAPPIST-1A, which is the star, also called two mass. It's just called two mass because of the place it was found, which was in the two migrant all sky survey, and this is essentially a red dwarf star, ultra cool red dwarf star, which is actually the most common in the Milky Way galaxy, in case you didn't know. And these let's cut this part out, but
all right,
it's not that bad.
no, you're cool.
We'll just wait like 3 seconds, and I'm gonna start talking again. So the surface temperature of the star is 2560 degrees Celsius or Kelvin. My bad. Um, this is the whole system's located in the constellation Aquarius, and it only amounts to about 9% of our sun, which is also slightly larger than the planet of Jupiter. Just to put it into perspective, the size of this star. Um, the farthest planet in the system, which would be TRAPPIST-1H, and it's the farthest from its star, and it reaches about the same distance of Mars in comparison to us. Now, what's cool about all seven of these planets is, as they were discovered in 2017, that they're all theorized to have habitable surfaces, and all of them would have a possibility of water. Now, this is no longer the case, as more research have found that some of these planets may used to have contained water, but not anymore, based off the surface temperature of some of these planets. I think I'll stop there, and then
All right,
James, you can talk about 1B.
so 1B, it is obviously the second planet from TRAPPIST-1, and it's located like 40 light years away from Earth in the constellation of Aquarius. It was found using the transit method, and it's the transit method is like where a planet dims the host star's light as it passes in front of it. So then they're able to detect the planet from there. It was discovered May 2nd, 2016, and even years later, there were more studies to refine its physical characteristics. And 1C, 1C is actually the third largest planet in the system, and it kind of has like Venus's atmosphere. It's kind of rock based on the bottom, and it has like a thick atmosphere of water vapor. And actually, what's really interesting about this is that one revolution on this planet, like one whole year on 1C, is 2 days to us. And it orbits like 1.2% the distance between us and the sun. So I think that's pretty interesting. And so, all right, so 1D. 1D is the least massive planet in the system, and it has a very poor atmosphere, similar to Venus, or a hydrogen poor atmosphere, similar to Mars or our planet and Venus. And its equilibrium temperature is about 258 Kelvin or 5 degrees Fahrenheit, which is still pretty cold, but it's still pretty livable. 1E. 1E, it's close to Earth size, and it's a solid, and it's orbiting the habitable zone. And E, F, and G, I believe, yeah, E, F, and G are orbiting the habitable zone around this star, and all these exoplanets are going to be 40 light years away from the Earth. And it was also discovered using the transit method when the star kind of eclipses the or when the planet kind of eclipses the star, and then we're able to see it better. All right, the planet 1G, it's about 150%, 115% the mass and radius of the Earth, and its host star compared to it. It's a distance of 0.047 astronomical units, and its atmosphere. It said it could have a global water ocean or an exceptionally thick stream of atmosphere lying over the ice. So its thick atmosphere, it could probably hold in a lot of heat, or a lot of temperature, and just keep it in.
Mhm.
But um, let's see, its orbit. Its orbit. It has a period of 12.3 days, which is the amount of time it takes to spin around its host star. And
I think the crazy thing about G is, and really about all of these planets,
yeah,
that like if you really think about it, we don't have pictures like you said. We found these using the transit system.
right,
So, and obviously there's that theory out there saying that it's like you don't know everything about space. So there's obviously going to be some materials, elements, just different things that we haven't discovered yet. And I feel like this goes for all planets. Like this one, for example, G. There's 3D models out there generated by the computers, but we really don't know what this planet looks like for sure.
true.
So it could be an egg. It could straight up just be hollow.
Could just
Nothing.
straight up an egg,
You
just
could
like
land
nothing
on
else.
that surface and fall through the other side. There's nothing in there.
There's got to be a
Obviously,
yolk in there.
it's got a core.
You said,
And that's the and that's the yolk.
and that's the
Exactly.
yolk. All right, you know,
There
I
you
got
go.
it.
Exactly. That's the core. But it could be that. It's just like in the egg white. I mean, I'm just saying.
Dude,
G,
if it's that,
the
if it's gonna be like that cool, like, isn't it just gonna be like super hard?
I mean, maybe, like, maybe not. You know. I digress.
We just gotta drill, like, you know, the Journey to the Center of the Earth. Yeah,
Yeah.
Journey to the Center of
Yeah.
the Yolk. That's what it is. We're just gonna make a movie
Exactly.
about how the
Should.
TRAPPIST-1 system is just
Yeah, we
all,
can really get our podcast out there.
yeah, it's just all eggs, and they're just trying to drill through this massive egg, and they're just trying to get to the yolk.
All right. So TRAPPIST-1H. It's got an orbital period about 18.7 days. That's its whole year. That's it. 3 weeks, and that thing's already had Christmas, New Year's, April Fool's Day, whatever. It's a lot smaller than Earth. A lot smaller than Earth. It's only about 33% mass of Earth, and it's got about 77% its radius. And it actually only has about half the gravity. Here's the interesting thing about H. It being the farthest one out, is one of the only ones in there that may be containing all ice, as in like the surface is 100% covered in ice. 1H, because of the distance from its much cooler star from like any other, like our star for example, it's really not that far away, and because the star, its energy output is only about half of a percent of the energy of our sun, it's theorized that this planet gets so little heat that it could be covered in all ice. And that's like the whole story behind TRAPPIST-H. But enough about that planet. We get into the history of it now.
Yeah.
So the star alone, which was just titled 2 mass at the beginning of what I said earlier, why it's titled that, the 2 micron all sky survey, in 1999 by a guy named John Geisus. And it actually take about 17 years for astronomers to realize there were actually 3 planets around the star, which was like groundbreaking at the time. You know, no one, we haven't, this is a time when like we weren't really discovering that many potential habitable planets, and they didn't know this at the time, obviously, but it was still a pretty big discovery. Later on that year, or just later on really, the Hubble Space Telescope from NASA would show us that TRAPPIST-1b it was 1B, C, and D. It showed us those three planets. So we had only thought there was three planets around the star at first. And from there, years on, but in about 2017, we really started getting into researching the TRAPPIST system, where we realized that a lot of these planets are unlikely to have hydrogen-dominated atmosphere, just like ones found in gas giants, which strengthens the possibilities that these planets could be rocky, have atmospheres, and have water. In 2017, using the Spitzer Space Telescope, we found that there are actually 7 planets. And the reason that the whole system is called TRAPPIST is because of the telescope that it was found with originally in 1999. That's just a little side note. And then, really, like James said earlier, EFG are in the habitable zone, so there could be life there. But a lot what has to do with determining whether life is possible on a planet is the star's age. Right now in the astronomy community, it's kind of unclear what older age means. However, older stars are a lot more stable than younger stars, which produce tons of radiation, solar flares that could kill everything on a planet in like a year. So older stars, they flare less and they give off less radiation. But it also could mean that the planets in TRAPPIST-1 have soaked up billions of years of these high radiations, which could have bowled off their oceans, which is what we theorize have happened for like planets B, C, D. Really, the only ones that we think could have water on them are planets G and H, just because of how far they are. It's sort of how we think about Mars. We think about Mars having water on it. There's a little bit of evidence on Mars that it had water, but it was because of its didn't have a great atmosphere. The radiation kind of boiled everything off, and the sun's high energy over all those billions of years dried up Mars, and that's kind of what we think happened to those 5 planets. And second, I need to. We'll just. That's right there. I need to read this one.
All right.
Now, despite a planet having old age, it doesn't necessarily mean that the planet's atmosphere is completely gone. I mean, that 100% is a possibility, but at the same time, it's not 100% that that's going to happen. Given that the TRAPPIST-1 planets have much lower densities than Earth, like there's a lot of them that are under half, or they're just above half the amount of dense as Earth is. Possible that there's like large reservoirs of molecules such as water that could produce thick atmospheres that would in theory be able to shield the planetary surfaces from the sun's radiation, flares, everything like that. Mm-hmm. And a thick atmosphere could also, like James was saying about some of the planets, redistribute heat and hold in all that heat to like some of the tidally locked planets, the dark sides, the planets, which would, in theory, increase the possibility of life on these planets. And the other thing to consider while about the TRAPPIST-1 system is, like I was saying earlier, you have to consider the age of the star. Now, astronomers believe that TRAPPIST-1a, or 2 mass, the star, is between 5.4 and 9.8 billion years old, which, me personally, that doesn't make any sense. Those are 2 completely different numbers with 2 whole different decimals, and that's like, that doesn't make sense to me. I don't know how you feel about that.
That's a really big range there.
That's a massive range.
That's a massive range.
I think dinosaurs died in that amount of time.
Dude, we were at the YMCA and we were trying to do this game, right? We were trying to guess about how many M&Ms are in this jar, and my friend gave out the estimation to at least 1,000 to 5,000 M&Ms in there. I'm just like, dude, that is stupid.
That's what NASA's done right.
That's what NASA's done right there. That range is just so unnecessarily. It's just like, it's stupid.
In my opinion, that's crazy.
Oh my god.
I mean, NASA. So I mean, it's about this star is pretty much 2 times older than our entire solar system is.
Right.
We're pretty young compared to, I mean, TRAPPIST-1, obviously. So there's a whole possibility that life could have been on there and gone.
Right.
I mean, this is it's opened up a whole like perspective
Right. It could
people are
have.
looking into.
And from the data from the Kepler and Spitzer telescopes, these telescopes determine that all of these planets are most likely all rock, which is really interesting, because all of our planets, they're all of them are not rocky surfaces. There are some of them are gas giants, some of them are just gas planets.
Well,
Well,
well, they we don't know. We can't really put.
well,
Well,
I mean,
okay.
can the
We can't
telescopes really
put
detect
things
like
into Jupiter.
land?
That
It's a gas giant. Like there's a whole like the
Yeah.
reason why it's got a mole is because like this big hurricane going on in the middle. But
maybe it's just a bunch of orange people running around.
yeah, true.
You know.
Yeah, a bunch of Trumps running around. Anyway, yeah, I didn't say that. Further research shows us that TRAPPIST-1 D, E, and F are unlikely to have hydrogen-dominated atmospheres. The only planet that we are truly clueless about is TRAPPIST-1 G due to its
Oh, is that
orbit.
so?
Yeah,
Oh, that kind of strengthens my theory about TRAPPIST-G being an
being
egg.
an egg.
Just saying, it's got the irregular orbit. It's got the cracked surface that the computer images showed us.
Uh-huh.
I mean, it's the closest thing to Earth.
True.
Oh,
You know what? Nah, I just gotta give it to you. It's an egg. Like there's no denying that
egg.
it's an egg. There's no denying
Yeah.
that. There's a yolk in the center. You know, if you crack it open, it's gonna be
Very hot
it's gonna be
yolk,
well
yeah.
done. It's gonna be well done.
crazy.
Push 1G to where 1B is at. Dude, that's gonna be a perfectly cooked egg.
Well
That
done.
that thing's gonna be a cuisine. Put that on a kid cuisine meal. Oh my god. All right. Anyway, these planets are actually so closely packed together with similar orbits, they are likely to appear as moons in each other's skies. So,
Dang.
so if you look up from say like 1C or something, you can see 1D as big as the moon we are seeing right now, and that is just crazy. Like I had no idea they were like this close to
They've
each
got to
other,
be. Some of them got to be bigger than that too.
right?
It's crazy.
Some of them can be
I wonder
like,
how that would affect like weather and stuff though.
yeah, true. Like if they had water, then the tides would be like
Because that's
way
another
bigger.
interesting part. We don't have very much information because we can't send anything over there because it's so far away.
Yeah,
We don't have a lot of information on its weather. Like, we started just researching this stuff in 2017, and we've just scratched the surface of this information.
true, true. And when I talk about tides, it just reminded me of that one scene in Interstellar where they're on that one planet and like
Oh, yeah.
that
the thing is
whole
mountains.
tidal wave just like almost engulfs him and kills him. I'm like
Yeah.
that would look so dope. That would look so dope. Most of these planets are thought to be made of metals like magnesium, iron, nickel, and non-metals like sulfur, oxygen, and silicon. In fact, iron is about 21% of the mass of each planet, which
Jesus.
those are the metals that we detected from the planets. But we don't know if there are certain elements in the planets that don't exist on Earth. Which, John, do you have something?
Yeah, I wonder how they figure that out and stuff.
Yeah, true.
Just saying, like, like you said, we've learned how to discover the planet using the transit thing.
Uh-huh.
You really, we can't send anything over there, so it really kind of leaves it open to um, like your own comprehension of the data that we have,
True.
what the possibilities of life could be over there. And I feel like that's another really cool thing about the TRAPPIST-1 system is, like I was saying earlier, it's like in its infancy of being discovered, even though it looks like it's past its prime. Well, we know it's past its prime.
Uh-huh.
So it's kind of cool to think about, like, if we could send a rover over there and look what we would find over there. Like, would we find something similar to Earth billions of years ago, where we can like dig under the ground and find like dinosaur fossils? Would we see creatures like that? Or even better, are there creatures like that there?
True. Or
Like on planet 1H where it's likely to be all ice. Are there creatures frozen in the ice?
True, that would be so good. We don't even have like official rovers, of course, because they're way too far,
Right.
and that would be so cool if we were to find like alien life on one of these planets. Like what you said, if they're like encapsulated in like ice caps or something, that would look so
Mhm.
cool. But or there could be like another colony of life that's like so small that we can't even see.
Right. Yeah.
That would look so cool. Um,
Like, doesn't make sense. It's ugly. It's got a mole on it. It's dumb. No one
yeah,
likes
that's
it.
a hurricane, dude.
Well, I don't care what it is. It's bad and looks stupid. I don't like Jupiter. So what if you got everybody on a treadmill
Uh-huh.
and attach this big strap around Earth to make it spin in the opposite direction that the gravity's pulling us in?
Yeah.
And then we increase the sun's gravity by like throwing propane at it or something. Then it brings Saturn closer and it wrecks into Jupiter, exploding it. And not only do we get their moons, we probably get a bunch of cool stuff too.
Oh,
Like,
so what are you saying? Are you saying like to pull the Earth in the opposite direction of its orbit?
oh no. I think you're very mistaken.
All right.
So, you're gonna increase sun,
Uh huh.
bigger sun.
Yeah.
So we would get sucked in because the gravity is too strong. So that's why the whole treadmill and the tracks around the Earth to make it spin away from the sun, and we're like it'll be like a tire,
Okay.
going away from the sun. But Saturn gets pulled into Jupiter, and Jupiter explodes.
All right.
There's no more Jupiter, and then we like decrease the size of. Oh, I didn't think about that. How do we decrease the size of the sun? Well, no, we would just keep rolling until we're in a safe distance. Yeah. We would just keep rolling until we're in a safe distance, and we would go like have moons in the process. Like our gravity would just grab the moons.
All right.
Yeah, I think that's pretty cool. I think that's a strategy we should do.
That'd be a pretty good strategy. Yeah.
I know. So you should. One little final piece before we go off here about the TRAPPIST-1 system is that unlike our solar system where the planets are made of very completely different things and foreign things from each other, like we have like 4 gas giants and we have 4 rockier planets. Unlike us, the TRAPPIST-1 system is astronomers believe that they are all made out of essentially the same thing, so they're all very similar. Um, Inside the planet, the resources are all the same. That really just that concludes our Travi Patty podcast about the
Oh
Travi
my
Patty
god, the
1
Travi
system.
Patty system. I hate that so much.
Travi Patty system. Travi Patty A. Travi Patty B through D. Not that cool.
Travi Patty E,
To be honest.
F, and G.
F and G. That's where it's
That's
at
where
right
it's
there.
at. The habitable zone, right
That's-
there. You know
The
that.
Goldilocks zone right there.
Yeah, that's the path of when you're not gonna get trampled and die.
These are like fresh off the grill Travi Patties.
Yeah, true.
And then like H is like on a whole different thing right there.
Yeah,
That's what's gonna get your ice cold Sprite cranberry
yeah,
a Christmas morning. You can't beat it.
right.
Very cool system.
Yeah. At 1B, at Travi Patty B, you're gonna get suffocated and you're gonna die.
Yeah, you're
like
dead
5 seconds. You're
instantly,
just
actually.
dead.
Dead. You can't even live there,
No, you can't.
bozo. Travi Patty C. Same thing. Just die in a different way.
True.
Die of radiation and suffocation.
Exactly.
Both.
Lack of an atmosphere. That's what happens.
Travi Patty D. What do you think about that one? Think about Trappist D. You're gonna die. Saying you're dead
Yeah.
instantly. Alien gonna come abduct you or something. I don't even know. EF and G. That's where it's at for real.
Yeah. There's no way you're dying there.
You can't. You got enough coats. You're chilling.
Literally, you're chilling. It's like 5 degrees Fahrenheit down there.
It's like 5 degrees. Literally, you're gonna be an ice cube.
Man, dripped
You're
out.
probably gonna die.
Man.
You're probably gonna die.
Yeah, you're gonna get dripped out though. Like you're gonna have some ice. Like literally.
Shut up.
I'm done, bro.
Anyway, thank you for listening to the Chatty Patty
Yeah.
podcast. It's been great with you guys. I'm James the Second.
I'm James the
My co-host
First.
and founder, James the First.
Yeah.
And please don't give us a midterm, Mr. Skipettis.
Yeah.
We tried
Please-
very hard.
yeah, we tried our very best with this. Please, like, be merciful.
It's literally 12. It's 12 in the morning.
Yeah, bro.
Right now. Please,
It's so late.
please, just don't make us take it. We're tired.
I just wanna,
We're tired.
dude. Please, I just wanna sleep right now.
Okay, you can end it right there.
All right, we love you, Skipettis. All right, bye bye.